Hello, today I'm going to talk about volcanoes and plate tectonics. So we've been covering plate tectonics and some of the effects. One of those is volcanoes. So we have an image here of the Earth and the interior of the Earth. We've got the inner core, outer core, mantle. So this is all melted rock, right? But we have to think about, why does the rock melt? We know there's heat, but where does the heat come from? So heat and friction form from the formation of Earth because the interior of Earth is so very hot, right? High heat and pressure will melt solid rock into magma. So this all comes from the early formation of the Earth. All that heat comes from when Earth was first being formed 4.5 billion years ago. So we're gonna get some melted rock. Now, taking another look at the inside of the Earth, some magma heats up more than surrounding magma. And we can see in this image here, we've got the core, and then we've got these plumes. So for whatever reason, because it's not equal, some areas heat up more than others. These are hotter than surrounding areas, and they will rise up towards the crust, towards the surface. This causes a plume that can force its way to the surface. And this is important because we're going to be talking about volcanoes. So somehow the magma here has to get up to the surface and through the crust. Okay, let's continue. So now these are some of the types of volcanoes that we see at plate boundaries. What we have here, so you'll notice two different plates. One plate is here and one plate is here. And this one is going underneath the top plate. This is very common. And what happens, and this has happened it happened in California and along the West Coast, was one plate was going under another plate. And that plate that's going underneath, you can see it starts to melt, and this magma rises to the surface, making all these volcanoes. So volcanoes found at subduction zones form from melting solid rock. This rock mixes with water and starts to rise through the adjacent plate. So part of this, you see the fluids here. Part of this is that melting rock mixing with the fluids causes it to be less dense, and it travels up, forming these volcanoes. All right, down here we have two plates that are pulling apart. So they're going in opposite directions. Usually we find this under the ocean. We see plate boundaries pulling apart under the ocean. When two tectonic plates are pulling apart, they form a thin line in the crust. So this whole region kind of thins out because they're pulling apart. This allows the magma to squeeze through, creating new land. So you get all these little volcanoes right here where the magma comes up, poking through the surface, creating new plate material or new crust. All right, let's move on. Now, sometimes with plates, we get volcanoes that are not at the edges of a plate. So, if we have a plate here, and we have another plate here, here's the plate boundary between them, right? This is where we've been talking about, is where they rub up against each other. But sometimes you'll get volcanoes right in the middle, or somewhere out, on the plate that's not near a boundary. It's kind of like at one of these spots, it's right in the middle. Some magma plumes break through the middle of a plate. This is known as a hot spot. So this hot spot here stays in exactly the same place. The plate moves over the top of it slowly over millions of years, forming volcanoes as that plate moves. the Hawaiian Islands were formed from a hotspot. And we see the big island of Hawaii here. That's where the current hotspot is. It hasn't moved. It's just the plate that has moved above it. And as you go along the chain, you get older and older and older islands. It's back. So at one point, this island was all the way back over here. And it formed when it was over this hotspot. The big island is currently sitting over the hotspot. All right, I hope this helps. Thanks.